Good morning, afternoon, evening, or whenever you're watching this video. Before we begin, we'd like to start with a land acknowledgement. The project site of the Waterloo Flight Center is situated on the Waterloo tract, land that was granted to the Haudenosaunee of the Six Nations of the Grand River and is within the territory of the neutral Anishinaabe and Haudenosaunee peoples.
The Heron Flight Center responds to the challenge of social, environmental, and economic sustainability with a high-performance thermal envelope that creates a welcoming occupiable space. We were careful in our material selection, curated views, and fenestration, and layered envelopes to create a bright and comfortable building that can be scaled and applied across the country. Using the region of Waterloo International Airport as a conceptual base, we organized the Heron Flight Center's main building and hangar as a cluster near the west edge of the site. This offered access to both taxiways and roadways and optimized the flow and layout of the plane parking for a more efficient flow upon entry, exits, and refueling.
In the main building, triple glazed, high-performance curtain wall clouds the northern exposure, allowing for diffused sunlight to spill in and an exciting view out to the runway. We chose to use timber and metal cladding and limited the window-to-wall ratio to better account for heat loss and heat gain. The flow of people through the space was another important factor. Students and staff enter through an intimate atrium before merging into an open, double-height, sun-filled space. Views toward the apron and taxiway drive the plan layout. The student lounge and flight dispatch run along the glass, while the classrooms, hotel and office space, and admin areas look onto these open spaces.
The circulation paths allow for individuals to prepare for their flights in the dispatch center right beside the runway, study, and socialize in the lounge. Or head to the second floor to the classes or hoteling office space. On the upper floors, the classrooms and hoteling office recede back behind acoustic glass partitions, which allow light to penetrate through the northern exposure without the noise of other spaces. Additionally, the movable partitions support mergeable classrooms for larger lessons or functions. These enclosures, along with other interior walls for the admin and lecture hall, further insulate the space that are occupied for longer periods of time.
Similarly, the hangar uses the uninsulated bay as a buffer for the glazing on the conditioned portion. Translucent polycarbonate panels clad the service bay, filtering light and providing levity to the large spans. The insulated section of the hangar optimizes the conditioned volume by creating a two-story form that opens on the uninsulated section on both levels. On both buildings, a large single-slope roof and cistern collect significant rainwater for greywater use, while providing ample space for the grid-connected PV array, which exceeds the requirements to charge aircraft and power the two buildings.
In addition to this, an extensive geothermal system under the apron provides ground source heating for both buildings and for a heat trace system for the apron and taxiway to reduce the need for harsh salts and ongoing labor during the long winters of Waterloo. HRVs and water-to-air heat pumps ensure high-efficiency heating and cooling, while LEDs, occupancy sensors, light sensors, and strategically positioned windows limit lighting energy consumption.
The exterior walls use an R44 assembly made of SIP panels and rigid mineral to wrap the envelope with continuous insulation. The panels limit penetrations through the enclosure, which, in combination with innovative hollow core mass timber slabs and a grid-based mass timber structure, lend itself to efficient prefabrication, transferability, and scalability. When all of these design choices come together, you get a beautiful, functional, and sustainable new flight center. Thank you for your time.